point of view regarding, businesses, consumers, or regulators that call for more accountability and transparency in some of these AI solutions? And, do you know if they've been able to kind of tackle that problem? Because transparency is always an issue, for certain businesses when you're discussing, AI or ML related topics. So that's a question around that. If you have any thoughts on that.
Absolutely. So AI is a very complex topic for people to understand, right? If you are trying to bring AI into your business workflow, let's say you're a credit risk team in a bank and you want to move towards machine learning to make lending decisions. Immediately, your business stakeholders, your credit analysts, your credit risk officers, your lending officers will all want to know, what's going on. Or your regulators, your auditors inside the bank might be interested in answering, how is this model going to work? Are there any weak spots in this model? When is it going to reject loans? When is it going to, accept loans? It's a very natural tendency for humans to ask questions when there is a black box presented, right? So, I'll get a little bit philosophical here. Humans as a species, we are able to scale so much because, we are able to scale trust. We rely on abstractions on every day. I go and, purchase something on Amazon.com with the trust that it's going to get delivered in a day or two, right? And that abstraction keeps me, do other things. And similarly, if I don't know that if Amazon is not giving me tracking into when this item is delivered, it's just a black box for me. Similarly, if I'm like an institution that is operationalizing AI for any use case, whether that is a regulated use case like lending or a non-regulated use case, for example, like e-commerce recommendation, I want to know how the model is working. Why is it predicting a certain item to me? Why is it actually improving our business metrics or not improving the business metrics? And that level of transparency is like something that makes every organization more efficient, more compliant. And by knowing these reasons, the data science and machine learning teams can build better models over time. If I know what's going on with the model, if I can debug the model, if I can fix operational issues, I can improve my model and my ML application over time and improve its performance over time. So it has multifaceted benefits. And we see ourselves as a platform that essentially, as I said, here, catering to helping data scientists cater to all of these questions, helping your business users build trust, helping your customer support teams to help answer complaints on your ML products, helping your IT operations team to monitor those models effectively, helping your compliance teams to, understand how the models are working. So that is our vision, is to provide the data science team a tool that they themselves can use, but also they can bring their other organizational stakeholders also to increase the transparency. And this in turn helps them, right? This helps the data science team to sell their models, operationalize them quickly, and get that business impact. The whole point of doing machine learning is to increase that business process efficiency and radically build new kinds of applications, and those are the values that get unlocked when you have this transparency and visibility. Hopefully that answers the question. Happy to follow up.
Can you describe how your algorithms relate to some of the open source explanation methods like SHAP and Lime, for example?
That's a great question. So we have productized Fiddler on a class of explainability algorithms called attribution-based techniques. So attribution-based techniques there is a difference between attribution-based techniques and non-attribution-based techniques. Attribution-based techniques rely on only probing the model with different counterfactual data and understanding the observations in the model and attributing them back to the features that you have changed. So for example, let's say I have 3 features, credit score, salary, and loan amount. And using that, I'm predicting some risk probability of the loan application. Now, attribution-based methods like SHAP fiddle with these, essentially perturb these features and look at changes in my risk probability and attribute them back to these features. Lime does not belong to this family. So Lime builds a surrogate model. So within attribution-based methods, we have a productized SHAP, but we also invented our own explainability algorithms using the original Shapley value. So Shapley value technique that came in the 1950s is actually the mother of all attribution-based techniques. And so this was invented by this person Lloyd Shapley, who was awarded a Nobel Prize for creating this attribution-based mechanism. He was inventing it in the context of game theory, and so now it's found application in machine learning. And so SHAP is one incarnation of Shapley values. We have our own implementation called Fiddle, which essentially is a proprietary technique that we have developed in-house. We have a paper that's out. We actually received a Best Paper Award at one of the AI conferences for this paper that we published. And along with Shapley values, there is various variants of it. There's another technique called integrated gradients that essentially relies on an Almond Shapley value-based technique. It's a slight different modification that works very well on deep neural networks because one of the problems with SHAP is that as you add more features, it slows down because it works in the worst case complexity is exponential to the number of features that you have, and so integrated gradients helps address that part for deep learning models. And so we have productized that. So Fiddler comes with a wide variety of explanation techniques, some custom, some open source, and that are available for the developer to choose.